This is my answer to homework number 3, question number 1. So the first part asks us to find B for a probability mass function given the top line here. So we use the theorem that for a probability mass function, the summation of all k's that make up the event space is 1. Essentially, there's like a 100% likelihood that an event is going to happen. So we can pull out b from this function. Okay, so that's going to be equal to 1. So we pull out b because it's a constant, and p lies from 0 to 1. And so this here is a standard geometric sum, and this is only possible when p is less than 1. And since we already know that p is between 0 and 1, then this holds true. And so this is just equal to 1 over 1 minus p squared when p is less than 1. So that's equal to 1 for a probability mass function. And then when we solve it, you end up with basically multiply both sides by 1 minus p squared, so b is equal to 1 minus p squared. So that's the answer for the first part. So for the second part, we're asked to find the expectation of x. So if I write out from what we got in the first part, essentially you're multiplying this summation here by k. So you end up with bk squared p times k to the minus 1. And again, we can pull out b. Essentially, we're multiplying a value by its probability over the entire event space. So that's why we multiply the whole thing by k. Because, as a reminder, we're looking for the probability of x equaling k. And when we pull b out, we have another geometric sum. And then we already know what b is because we solved for it up here. So when we write this out again, this here is equal to 1 plus p over 1 minus p cubed. And so this cancels with this to equal 1 plus p over 1 minus p. And so we use a similar technique to solve for the third part of the question, where here we're asked for the event occurrence for x squared. And so essentially we're just multiplying this summation by another k. So we can write that out as, again, I'll just keep the b out this time. K equals 1, k cubed, p to k minus 1. And again, we know what b is from the first part. And then the summation of k cubed times p to the k minus 1 that actually ends up equaling, it's a little messy, but it's 1 plus 4p plus p squared over 1 minus p to the 4. Okay, and then when this cancels with this, you end up with 1 plus 4p plus p squared over 1 minus p squared. So essentially the technique across all this is to use the geometric sums. Okay, and then for the last part of the question, we are looking at, I'm just going to write the given values here. So we have, oh no, sorry, it's the second to last part of the question. So in the fourth part of the question, we're being asked for e of x squared minus e squared x. And this is essentially the same as e of x twice. So to solve for this, you're essentially just taking this. So we're taking 1 plus 4p plus p squared over 1 minus p squared. And then we are subtracting 1 plus p over 1 minus p squared. So if we write that out, this one's more of an algebra problem. Sorry, this is plus 1. We can actually keep this as 1 minus p squared because we can use the same denominator. And so that ends up looking like, well, we know it's all going to be over 1 minus p squared. So we have p squared minus p squared, 4p plus 2p, or sorry, 4p minus 2p, so that's just 2p. And then 1 minus 1, so it's just 2p over 1 minus p squared. Okay, and then for the last part of the question, here we're given that p is equal to 1/3. And we're looking for the conditional probability mass function. So we have x equals k again, but this time it's with x ranging from 2 to 5. So if we use our formula for Module 1, where we have the probability of A with condition B is equal to probability of AB over the probability of B. So because we know that b was equal to 1 minus p squared, and we know p is 1/3. When we sub that in, we get that b is equal to 4/9. And so when we use the formula that was given, we end up with 4/9 times k 1/3 k minus 1. And then we sub in to solve for the denominator. So essentially the probability of b looks like the sum of k equals 2 to k equals 5 of this function here. So the b, here I'll just write b, k, the p to the k minus 1. And so when you solve for that summation, you end up with about 0.538. And so the final answer looks like 4/9 times 1/0.538 times k 1/3 k minus 1 in the event that k is equal to 2, 3, 4, or 5.